Let's talk a little bit about Derive sketches and how they can be used to use in top-down design and parametrically control parts in an assembly and the overall assembly. I've got an example here of a toolbox, and I've written a Visual Basic program that writes out a text file. And let's try this just to see if everything's working here. The box width current is 10. Let's go to 11. The depth, let's just make it shallower. Let's see, we'll go to, yeah, I think it was originally 9. So the lid depth is 2, make it a little bit deeper, and that one even deeper still. And we'll just update this file and regenerate this toolbox. To see if it will update all of the files, the individual parts in the assembly, and generate a new toolbox. So it did, and if we check the clearances internally, looks like we've got a little issue with the handle in there, but we'll work on that later. It looks like that all of the other geometry, the hinges and the latches out in front, and all of the other dimensions updated properly. Let's try that one more time. Go to one that's not quite so long and a little bit deeper, or the width is a little bit wider, and the depth will go to 10. Lid depth we'll just say is 2, and the tray depth we'll say is 2.5. We'll leave these default dimensions for the offset and draft and so on. We'll leave those. We'll just update those and regenerate the toolbox. And again, it updates, creates a new toolbox, and it looks like this time everything came in okay. Internally, we've got our inside trays, our interfaces here between the tray links, everything updated without getting any failures in our feature tree. So I think it's working pretty well. Let's save this off, and let's just take another really very simple example. I've got a cabinet with 4 drawers, and instead of a Visual Basic program, this time I create a little macro, and we'll try that macro. Again, similar kind of concept though, just prompting for the height. It's 78, the width. In this case, this dimension here was 65. The depth in this dimension here we'll say is 36. Top space distance we'll say is 3 inches. Bottom space we'll say is 2.5. The side we'll say is 1.5 inches. The space between the cabinet space distance, probably should give a better definition on that. That's the drawer space, we'll say is 2. And then between the faces on the drawers, we'll say is 0.75. And the third drawer we'll say is percent of the others is 1:1. And we'll update this. See if it generates our new cabinet. So let's take a look as to how we're using Derive sketches to create this parametric file. I open up this control file. It's just a dimensioned a number of dimension sketches that define the base cabinet and the individual drawers. and they are tied to variables. I'm going to delete one of these. If we have to go to that drawer, that's the fourth drawer. Let's delete that one. And of course, if we now give that a dimension, and when it prompts us for the dimension, we'll just say equal to a global variable, and that's going to be the bottom space dimension, which is 2.5 inches. So I've tied those dimensions to global variables, and if we take a look at what those look like, this list of variables is actually tied to a text file. That text file contains those variables, and that text file is being written to by my macro. So let's create a new one. I'll use this. It's just a it's got a back plane here. Let's so that's also code to a variable. If I erase that one, I'd have to actually edit that back plane, looks like. And here's the dimension that it's set to is 36 right now. Let's we'd have to show that back plane. Let's show the annotations here. Okay, so I've changed the dimension, so it's just a constant dimension. The back plane, if we looked at that definition, it's set 36 inches from the front plane. If I want to control that with a variable, and again, say that's equal to the global variables, the depth. And of course, I can display these by turning on my annotations here. If I turn them off, see, I can turn those feature dimensions on with that link there. So I've got this control sketch. Let's create I'll save this off as a new file. Let's say save as, copy and open. Let's create our demo here, control demo, and chest of drawers demo control. We'll save that and open it. And I'll create a new assembly and insert that drawers demo control into the first part in my assembly. And now if I create my chest, my cabinet, and the drawers, I would just say create a new part, and we'll save this off as my cabinet. And let's save as, copy and open my drawer 1. Save as, copy and open drawer 2. Save as, copy and open 3. Save as, copy and open drawer 4. So then in my assembly, I can just insert each one of those empty parts. So insert drawer 2, insert drawer 3, and insert drawer 4. Now, all of those are empty parts in this assembly. And if I now save this assembly off, we'll call this my cabinet or demo. And if I edit my cabinet, this is the main base. And I'm sorry, let's edit the, I've got the control, I've got each of the drawers. Let's insert the cabinet here too. We've got to insert the base cabinet. And I'll put that at the top. I'll put it before the drawers, but just under the control file. So I've got my cabinet and then the 4 drawers. So let's edit the cabinet and expand the chest of drawers control file that has just the sketches in. If I expand also this empty cabinet file, I'll select the front and control select the base cabinet control. So that's the overall size. It's 65 wide and 78 high. And with those two features selected, the front plane and control select that one, I'll say insert a Derive sketch, and then I'll locate that sketch, make sure that it's at the center, and make it coincident with the center, and then orient it so it is constrained in its orientation as well. And so that sketch is dependent on this base cabinet control part. And I can now use that, and let's turn on our planes here. Small back there, let's make it a little bit bigger so we can see that there's the back plane of my cabinet. I'm going to take this sketch and extrude it up to that surface. And let's shell this. We can use another top-down technique of split part or insert part to create the different panels of the part. Let's make this 1/2 inch thick. And let's go ahead and set the color on this as well, right while we're here. We'll make it a, let's expand our wood and go down to oak. We'll make it out of oak. So there's our cabinet. And it's, all 4 sides are completely covered, but yet it's hollow because we've shelled it. So if I now close this one, well, let's see, let's keep that edited. We'll edit that cabinet, and again, we'll come to the front plane, and we'll select the top drawer control, and again, insert Derive sketch, and locate it, and orient that so it's completely constrained. And we'll use that now to cut the clearance hole for that first drawer. We'll say up to next. There's that one. Let's cut the second drawer clearance. You'll still have the base cabinet edited. Go to the front plane, second drawer, insert a Derive sketch. I'm going to snap that to its origin and orient it So it stays in position there, so it's completely constrained. And then I'll cut that up to next, and so on. I can continue that with the others. Let's create the drawer itself. I would continue on, but that's just repeating the same thing. So again, here's the control. There's the cabinet that we've now created. Let's create this first drawer. So I edit that drawer, go to its front plane, come to the chest of drawers and use the same sketch, the top drawer control, and we'll say insert derive sketch. And make sure that's completely constrained. And instead of using that, let's offset that. Let's use that derive sketch there. We'll sketch on the front plane again. But we'll take that derive sketch. Let's offset so we've got a clearance between the, let's go reverse. And I'm going to change my units here. Okay, that should. Okay, let's say that's just a 1/4 inch, or 1/8 of an inch, 0.125. So now I can extrude that, and let's extrude it offset. So we're offset maybe 1 inch from the back, and it's offset from that surface there. So I'll have clearance there to the back of the cabinet. And let's shell the parts out of that. We'll shell the top and the front on that. And let's go ahead and color that. Okay, so let's turn off our annotations there. We don't need those. We'll turn that one on and expand it out and go to the annotations, right click and turn those off. We could also turn off our sketches for the time being. So there we've got our cabinet, base cabinet with makings of our first drawer there. And let's add the face to that drawer. So again, I can edit my drawer, go to the control, again, come to the front plane, select that one, come to the top drawer face. So it's dimensioned in this control sketch, so it's a function of how large my drawer is, and so it's automatically set those dimensions, which are part of my variables. I can control those. And just say insert derive sketch. And let's turn on our, go back and turn on our sketches again so we can snap to those. Easy to make those points coincident that way. And we'll just use that derive sketch there directly. We don't need to offset on that one. Let's just come out to the front. We'll say that this is maybe a 3/4 inch face on there. And we can continue on with that kind of process, creating each of the drawers. And you could add additional features on there like I have in my chest of drawers, where I've added handles, added chamfers, added different cuts and so on, those individual pieces to make them more realistic. Then once you have your cabinet done, and if you control it with a macro, which I've done here, I've controlled the text file with a macro. You could do that with a number of different ways. You could even use Notepad, pardon me, Notepad to edit those variables. If I opened up those variables right there, so let's change it to 62, and the width is 36, and the depth is 24. Let's just save that off. I think that's this variable file that we're using to control this. You can see that it creates a new file cabinet just by changing those variables. And of course, you could do the same thing. You could go to the control file, edit these, unlink it, unlink this this model to this text file, and then just change them directly here if you wanted as well. So let's end this. Maybe I'll attach another portion. Well, let's see, just to show you the complexity, or the level of complexity you can go to in this kind of modeling technique. If I open up a file that's a model that we've used the same process to parametrically define filter plates of a company, a local company. You see the level of complexity and detail that as soon as that loads up of a filter plate, and they have dozens of different basic sizes, and then with each size they have several hundred variables that control all of the features on the filter plate. The type of grid pattern, the number of what they call cloth dogs, the type of handles, the type of cutouts there for the handles to sit on the rails and so on. All of that information is controlled with a control file using Derive sketches. If we look at the control file here, there's the control file, and it's all controlled with dimensions. If we looked at the individual dimensions on there, have several hundred variables that control these all these features, and it goes down quite a long ways. Long list of variables. So you can get very sophisticated in generating the type of features you have, and of course this has an associated drawing with it. So as we finish the model with the variables, inputting those variables, we can then update the drawing very, very quickly. You don't have to create it from scratch. So here's an example of the shop drawing that's created, which is sent to production for their process planning and creating the shop routers. They know which features they have to go through to create this filter plate. And those are all created by filling out this form that is, again, a Visual Basic program that is used to define all those variables. And once that is filled out, you can save those off, which then controls the part and the assembly. And it looks like it's slowing down a little bit here with all the things that I have loaded. I should probably close out some of these parts here that I have. Well, that's all I need to show for now. I'll try some additional demos with the power of Derive sketches.